Packet switch X.25. X.25 is actually a protocol suite for packet switch data communication in wide area network. This is actually a legacy network lay protocol. A typical application are point of sale card readers, and the speed is actually between 2400 bit per second to 2 megabit per second. It is actually now declining, but still used in many parts of the developing world. It describes the procedure necessary for establishing, maintaining, and terminating connections. Use data communication equipment, DCE, which is connected to packet switching exchange, PSE, through a public switching telephone network line. So it provides extensive error checking and flow control. Another type of protocol is frame relay. It is a protocol at the data link layer. It implements no error or flow control. The data rates are up to 4 megabits per second. It is actually a little slightly higher than the X.25. Router on the LAN needs only a single interface. A short leased line to the frame relay network edge allow cost-effective connection between widely scattered LANs. So it is actually mainly used as a one big backbone to connect a number of LANs. In a frame layer, you have DTE as the router and DCE as the frame relay switch. Connection from DTE to DCE is through T1 or E1 line. The third type is asynchronous transfer mode, ATM. This is a technology capable of transferring voice, video, and data simultaneously through private and public networks. It is built on a cell-based architecture. The ATM cells are always a fixed length of 53 bytes, which is 5 bytes for the header and 48 bytes for the ATM payload. The design goal is actually to optimize the use of high-rate transmission media, can interface with existing system. This is important. Can be implemented inexpensively so that cost would not be the barrier for adoption. Be able to work with existing telecommunication hierarchy. Must be connection oriented to ensure accurate and predictable delivery. To move most of the functions to hardware and eliminates as many software functions as possible. So this is the ATM cell, a synchronous transfer mode cell with 53 bytes long, with the 5 bytes of header and 48 bytes of payload. Cell switching. Problem of the packet switching. Variety of packet sizes make traffic unpredictable and it's difficult to provide consistent data rate delivery. So it is solved by using the concept of cell switching. Similar to packet switching, but the unit of transfer is a cell, which is a small data unit of fixed size. So it's a fixed size in cell switching. So this is the relation to the OSI reference model. One operations focus on layer 1 and on layer 2. One access standard describe both physical layer and data link layer requirements. Standard describes how data is encapsulated for transmission. So this is the diagram, right, for connecting LAN in a one environment. Data link layer concept in one. The data link layer defines how data is encapsulated for transmission to remote sites and the mechanism for transferring the resulting frame. A variety of different technologies such as ISDN, frame relay, or ATM are used to move data across one connection. Many of these protocols use the same basic framing mechanism such as the high-level data link control HDLC. The most common data link protocols are HDLC, PPP, and frame relay. ATM is different from others because it uses small fixed cell of 53 bytes, unlike the other technologies which use variable size packets. Another data link layer protocol is the multi-protocol label switching, MPLS. It is increasingly developed by service providers to provide an economical solution to carry circuit switch as well as packet switch traffic. It can operate over an existing infrastructure such as IP or Ethernet. MPLS is a standard approved technology for speeding up network traffic flow and making it easier to manage. MPLS is called multi-purpose because it works with the Internet Protocol IP, the Synchronous Transfer Mode ATM, and the frame relay network protocols. So the reason for migrating to MPLS, it converts services available, voice, video, and data, any to any connectivity without the high cost of individual circuits, advanced features for ingress and egress routing policies, load sharing, policy routing, secure flexibility or adding future business and partners, multiple VPN support, and circuit consolidation frame. An MPLS-based network consists of routers and switches. Customers connect to the backbone network through multi-service edge. The backbone comprises the core routers that provide high-speed transport and connectivity between the MSC routers. And MSC routers contain different types of line cards and physical interfaces to provide Layer 2 and Layer 3 services including ATM, FR, Ethernet, and IP MPLS VPNs. So data link layer concept for WAN. Dedicated point-to-point, you have packet switch and circuit switch. MyRAN is Malaysian Research and Education Network. It is an example of public WAN. It is launched in 2005, started with 12 universities, and currently has 100 universities, polytechnic, and colleges. And it is centered in MSC, Putrajaya, and full funded by the government. So this is the diagram of the Malaysian Research and Education Network, example of the WAN, public WAN. Trans-Eurasia Information Network. It is launched in October 2000, linking France to Korea. First large-scale regional data communication network. Provide dedicated high-capacity internet for research and education communities. And later more powerful network link up to 10 gigabit per second. So you have series of TEIN 1, 2, 3, and 4. UCAM network is an example of a private WAN, where the new architecture of UCAM network is an MPLS-enabled network. This is the previous network architecture. Now, UKM network architecture linking all the research centers, the campuses,